Everybody fueled up? We got enough coffee? Imastetimi, are we ready? We're almost at the end. We've got one or two more. So it gives me great pleasure, once you've taken your seats, please do take your seats. If you sit in the middle, you can hear better, right? Okay, or in the front row over here, there's some good positions here too. So our next speaker is Steve McDonald. Steve has a lot of years of experience, 17 years of experience with building software, leading teams and transforming organizations. He's been working in Agile since the late 90s, I expect, or was it early 90s, Steve? And since then, he's been gaining experience in Scrum and Kanban, amongst other things, mainly working in finance, right? We've got a very strong finance track today. And Steve is currently with Tesco, heading the identity department. So give me a big round of applause and welcome on stage, Steve McDonald. Thank you, Steve.
Hi, everyone. So I'm at an interesting stage in my career. I've just finished at Tesco, actually, so I don't work there anymore. And I'm going to start a new role on Monday. I've had the last week off, which has been lovely. But it's given me a chance to think about the last couple of places that I've worked. And in both places, we were embarking on that journey towards continuous delivery. And in both places, stability was really important, and availability was really important. And on the development side of things, we took more or less the same approach. But on the operational side of things, we took completely different approaches. And that's what I want to talk to you about today. So first off, hands up, how many of you work in ops? Okay, a handful. How many of you are developers? Everyone else. Okay. So for the developers, how many of you feel responsible for the system that you write when it's in production? How many of you get called 24/7? Hands up. Okay, maybe a quarter. So who does the support for you? It's that handful of ops guys, I think. And every company that's doing the transition from waterfall to agile to continuous delivery, everyone wants to go fast. And that's why people are doing it. You want to go fast because you want customer feedback. You want to evolve your product. That's good. Maybe you want a more stable system. How does that work? You want to go fast. You want to make more change on your system. Maybe you want to change it every day. Maybe you want to change it multiple times a day. But you don't want it to go down. How do we do that? Oh, this doesn't work. Nothing works. Oh, okay, there we go. So, I think if you're looking at Agile in general, Dave Thomas had a very simple explanation of it, which is find out where you are, make a little change, adjust your understanding based on what you've learnt, and then repeat. And that for me is the simplest definition of Agile. And that's what we wanted to do at both these companies. We wanted to release little and often, but we wanted the system to be highly available. Now, Facebook had a very famous saying, which was go fast and break things. And what they were saying in that was that they valued speed, they valued the evolution of their product, they valued customer feedback over availability. Now, I flew in from London yesterday, and I'm really glad that whoever writes the software for Athens air traffic control didn't take a go fast and break things approach. It's clearly not applicable to all domains. Perhaps it's not applicable to all companies. And interestingly, a couple of years ago, Facebook changed that ethos. They changed it to go fast with stable infrastructure. And maybe that reflects the evolution of that company. But certainly, if you're working for a company that has an established customer base, that has an established revenue, that is based primarily on the systems that you're writing, going fast and breaking things doesn't seem like the right approach. So the two companies that I'm talking about, the first is SagePay, and they're a payments processor in the UK. So they service small, medium-sized businesses. And if you want to get a website online and start taking payments, you go to SagePay and they set you up with an integration, and it does most of what you need to take credit card payments. It deals with a lot of the security, things like that. But that means if SagePay goes down, 65,000 businesses across the UK can no longer trade. And you can imagine these businesses get quite annoyed when this happens. And at Tesco, you know, one of the largest retailers in the UK, with a massive amount of revenue coming from their online business, if that goes down, it has a direct impact on the bottom line. But that's not true for everyone. It's not true for every company. So one of the first questions I think you need to think about is, where do you sit on this scale? Can you live with 1/9? Can you live with 90% being down for 36.5 days a year? Or 36.6 days on a leap year? Maybe, maybe not. Do you need to be 2 nines, 3 nines, 4 nines? Well, this is where it gets really hard. 5 nines? Or do you need to be even more than that? And there's a massive difference in the cost of each of those nines. So not just the investment that you have to make in kit, if you're not in the cloud, not just the investment that you have to make in time, but also the opportunity cost, the things that you don't do because actually you need to concentrate on availability. And both companies that I'm talking about were aiming for north of 4 nines, so higher than 4 nines availability. Aiming for 5, but perhaps not that bothered if we didn't get there. And that's going to be one of my first questions. When I start at a new company on Monday, that's what I want to find out. How available do we need to be? Because it has a material impact on the investment that we've got to make in it. So if you want to go fast, you want to be highly available, you have to optimize for mean time to repair over mean time between failure. Has everyone heard of these two phrases? Blank looks, some nods, some hands, okay. So the mean time to repair is just the time it takes you to repair your system when it goes down. How long does it take from failure to get back to normal operating? A mean time between failure is how long is it from the start of one failure to the start of the next failure. And traditionally, people focus on the mean time between failure. Because if you can make it a really, really, really long time between failures, then you can get lots of uptime, lots of availability. The problem is, we've just said we want to make change all the time. We want to deploy continuously because we want to get feedback. So we're going to break things. Nobody's perfect. Even if you are an incredibly disciplined team and you're following all of the practices that you can think of, things are still going to go wrong. Every time you make change on a system, it's a risk. So by optimizing for the mean time to repair, what you're doing is you're making sure that each of those failures, the impact is reduced. So how can we go about that? You know, there's a ton of different techniques to do this. You can do canary testing, blue-green deployments, feature toggling, circuit breakers, traffic management. You know, all of these tools you have in your arsenal to reduce the impact of failures and to minimise the mean time to repair. But if you're shooting for 5 nines, you've only got 5 minutes in a year when you can be down. That's not very long. That's not long enough to call someone at 3 o'clock in the morning, for them to get out of bed, turn their laptop on, log into the VPN, and go and fix a problem. Not even close. You might get away with it for 4 nines. You might be able to have an incident, maybe 2 that are manually resolved with 4 nines, because you've got 50 minutes to play with. But really, you want to automate this as much as possible. You want to be prepared for failure. So hands up if you've come across Chaos Monkey from Netflix. Okay, 3 or 4 people. So Netflix developed this tool called Chaos Monkey. And what it does is it injects chaos into your environment. It basically runs around the Netflix environment, turning servers off in production, just to see what happens. And they do this every day. They do it from 9 to 5, you know, normal operating hours, because people are in work, people are looking at the systems, people can respond quickly if something does go awry. But really what they're testing is they're testing that their system can respond to failure. And if you're going to have a highly available system, you need to do things like this. But all of these concerns, they sound really operational. So what's it got to do with development? Well, hands up if you've heard of DevOps. Who's heard of DevOps? Okay. So DevOps, to me, is about bringing development and operations closer together. It's getting them on the same page. It's making sure that when you're doing development, your operational concerns are at the forefront of your mind, that you're dealing with some of those operational concerns just as you're dealing with features. And so I tried to write up here all of the, I mean, they're buzzwords effectively, but all of the principles that I think are encompassed in DevOps. And we've only got 45 minutes, so we don't have time to talk about them all. But there's a couple that I wanted to point out. So the first one, at 12 o'clock, everyone together from the start. And this, for me, this is the embodiment of DevOps. Everyone, no matter what team they're in, whether they're in development, whether they're in operations, whether they're in security, everyone has the same goal. Everyone is aiming for the same thing. And everyone's working together from the very beginning. And this is just, I think, the most important thing about DevOps, because as soon as you have handoffs, you have dependencies, and dependencies are slow. As soon as you have handoffs, you don't have the same richness of communication that you have when people are in a team together. So you don't understand each other as well. So you get a worse result. So the other ones that I wanted to point out, so there's embrace failure at 10 o'clock, and there's no blame at 5 o'clock. And these two really should be next to each other, but I didn't think that hard about it. Because you can learn from failure. You have to learn from failure. You have to accept that you are going to fail, right? There are going to be screw-ups. But you have to learn from them. And how do you learn from them if you've got a culture of pointing your finger and saying, that was Bob's fault, that was Steve's fault? You can't, because people won't be open. People won't come forward and say, you know, this thing I did, I think it caused the problem. So you have to have that kind of no-blame culture. And then every failure you have to analyse it. You have to work out why it happened, and you have to learn from it. So I want to talk now about the first company, SagePay. And in SagePay, we took a DevOps approach. And in 2012 in SagePay, we did a release in November. And that release was the culmination of about 9 months worth of development work. It was a huge release. It took a while to get it out. A few things went wrong. But finally, the release went out and everyone patted themselves on the back. Or at least the dev team patted themselves on the back and went down to the pub. The call centre started seeing increased number of calls. And the next day, they saw even more calls and more calls. And so many calls came in as a result of this release that they had to hire a bunch of contract staff to help man the phones. The teams that were in the call centre couldn't take a lunch break because they had to be on the phone. Their managers went out and bought them pizza and delivered it to their desks. And we had this, and you can't really read this because this is a very well-used brick, but on that brick is written Susie's break brick. Because everyone in Susie's team, if they wanted to go for a break, if they wanted a coffee, they wanted a cigarette, they wanted to go to the toilet, they had to take the break brick with them. And that's how they ensured that they had the most number of people on the phones to deal with this increased volume of calls. So this release had a huge impact on the quality of life for these guys in the call centre. It had a huge impact on our customers. Because clearly, if they're ringing the call centre, they're probably unhappy. There were problems. And really it was this release that galvanised the transformation at SagePay. So we started off the transformation and we wanted to try and make sure we were doing the right thing. We were clearly going to put a lot of time and effort into it. So let's just be sure this is what we really want. So we sat the leadership team down and said, what do you want? What do you want SagePay to be with regards to technology? And they gave us a list of 8 or 9 things, but the one that really sticks out in my head is this one. Stop us being scared of changing our systems. Because at this point, we were terrified of changing our systems. We just messed everything up. And what we wanted to make sure was that they understood how difficult this was going to be. This was not a small change. This wasn't a case of just saying, let's do TDD and everything will be fine. It was a much bigger change than that. And we wanted to make sure that the business understood the investment that they were committing to. They were going to have less features delivered. They were going to see lots of tickets about technical debt, lots of tickets about re-architecting stuff. And they were fine with that. This doesn't feel like the goal that you go to your technology department with, though. It's a really emotive statement. Stop being scared of changing our systems. You know, the reaction that you're probably going to get is, well, I'm not scared. I'll change it anytime. Or perhaps you'll start to see people becoming less risk averse and start to change the system just because they want to prove that that's not true. And that wasn't the behaviour we wanted to drive. So what we wanted to do was get across to everyone what we were doing and why we were doing it and why it was so important and what really that was going to look like in the future. And has anyone come across the work of Tom Gill? No, okay. Google Tom Gill. There's a great TED talk that he's done around quantification. It's only about 10 minutes long, and he quantifies an abstract concept. He quantifies love in that particular example. And his point is that putting a number on something makes it really clear what you're talking about. It's an aid to thinking, an aid to clear thinking, so that when you're trying to put a number on it, actually you've got to think really hard. What do I mean when I say this? But also, as a way of communicating out to a bunch of people, to share an understanding with them, is probably the most powerful tool there is. So we wanted to quantify this. And we couldn't just say, we don't want to have another big incident like we had in 2012, because that doesn't really tell our teams what we want to do. We couldn't say, we want call volumes in our call centre to go down by 50%, because again, it's the right goal, but it's at the wrong level. It doesn't tell me as a technologist what we need to do. So we had to decompose it down further. And so this is what we came up with. Oh, there we go. We're going to do a production release at least once every week. Now bear in mind, this is a company that's just done one release in 9 months, and that release didn't go very well. This sounds crazily unachievable. But everything came out of this. Everything fell out of this particular goal, or certainly in the dev world. So how do you go about releasing every week if you're used to releasing every month? Well, you have to sort stuff out. You have to sort your processes out. You have to sort out your automated testing. You need to write automated tests. Maybe you need to put your source code in source control. You know, things like that. It drives all of these kind of behaviors. And the nice thing about this goal is it gave our developers a tool to cut through arguments with the business. So maybe the conversation goes something like, why are you so slow? Well, we're all doing TDD. Why are you doing TDD? Well, because we want to do a production release every week, and we want to make sure that that release is doing what we say it's doing. And that's what we've agreed, and that's what the leadership team have agreed. It cuts through that debate quite quickly, so you can move on and you can actually get on to doing it. We also had a goal of 4 nines availability, and we defined availability as, or rather we defined downtime as less than 50% of the normal rate of transactions going through the system. So if we dipped to 49% of what we would consider a normal rate of transaction, we considered ourselves down. And we wanted to make sure that we were down for no longer than 50 minutes in a year, or thereabouts, including any scheduled maintenance. And again, this is intended to drive the right behavior, to incentivize us to worry about downtime. But we made a big mistake. So I was looking after the dev teams, so I said this a lot, production release every week. The head of ops was saying 4 nines, please. And we're in conflict now. The developers want to make change quickly. And the ops guys are going, whoa, don't change my system because you might break it. And we've got to hit 4 nines. And so things, innovative ways of solving problems got shut down. So for example, our developers wanted to automate schema changes. And they looked at DB deploy and thought DB deploy was a good tool to do it, so they implemented that in dev and UAT. And then they wanted to release it to production, and the DBAs turned around and said, no way. It's going to break things. You can't do it. End of discussion. So what we did, and I can't believe we didn't realise this ahead of time, but hindsight is wonderful. We shared those objectives among both the dev team and the ops team. So all of a sudden, our developers were incentivized to worry about the availability of the system, and our ops guys were incentivized to worry about the speed of change. So finally, everyone was starting to work on the same page. And that particular DB deploy conversation became one of, okay, why can't we do it in production? well, it's because our dev and UAT databases have slightly different schemas. How can we fix that? And so we started to see people having questions around how we could make things better rather than just saying no. But all of this was difficult, really difficult. We're asking people to work in a completely different way to how they used to. And change is hard, change is scary. But also, when things get really hard, that's when we stop doing things. So you start off and TDD is a nice idea, but it's really hard to do it well. So what happens? People stop doing it because it's hard. And so we mandated to the teams that there were some things that were non-negotiable, some things that we had to do. And this was Scrum, by the book, exactly as it says in the Scrum Guide. No saying, oh, we're not going to have a retrospective this week because we've got nothing to talk about. No missing planning meetings. No saying, oh, we've got nothing to demo, so we won't have a demo. Do Scrum by the book, until we got good enough that we could then start tweaking it and changing it to suit us. Same with pairing. Everyone pairs on all code, production code, test code, infrastructure code. Everyone pairs on it all the time. And the bottom one, I think, is key. Everything around availability, certainly, and around speed, stems from technical excellence, from taking the time to do things right, doing things as well as you can. And we set that bar as high as we felt we could, and then tried to make sure that the team stuck to it. And again, this mandate was a tool for them to have conversations with their product owners who were saying, can I have another feature, please? No, hold on, we've got to do some refactoring. Or, hold on, we've got to improve our test suites here, or how fast our CI build runs. And I think a couple of these hit some of the oaths that Uncle Bob was talking about this morning. So this was difficult, particularly for our developers, clearly a bunch of new skills to learn, but also for our ops guys. Automation. How do we do that? So we had to support the teams through this. Right? So we had to give them the resources they needed to learn these new skills. And that meant bringing people in, bringing experts in to talk to us, bringing experts in to coach the teams, to sit with them, to pair with them, to get them thinking in a different way. You know, we had to spend money on books, spend money on courses, spend money on sending people to events like this, and just give people space to learn. We sat people together, and this makes a huge difference. So when we started off, we had our testers over there, our developers over there, and ops in the middle. As soon as we started mixing that up, as soon as we started sitting people next to each other, then stuff really started to happen. People started to understand the concerns that others had. So developers started to understand the testers' concerns, and they started to be able to help them write automated tests for those concerns. We started to share knowledge between ourselves. So we started up tech talks, which is a couple of hours every week where someone in the teams just talks about something interesting that they've learned. And that's still going on. And it always amazed me. We had a fairly small team, maybe 50 or so people, but there was always someone that had something to talk about. And we got guest speakers in and things like that as well. But just starting to get that culture of learning. But you have to allow teams to explore. You have to allow them to learn for themselves. So if you've got a toddler, a small child, you'll let them touch a radiator. It's hot. They touch it, it hurts a bit, they don't touch it again. You don't let them put their hand in an open fire. And that's the kind of approach that we took. If we thought we could see a team that was going to make a really critical mistake, then we'd try and step in and help. Otherwise, we'd let teams explore, let them experience failure and learn from it. But in order to do that, you've got to get rid of any fear in your company. And this comes back to the no-blame culture. And you've got to do less stuff. You're asking people to work in a completely different way. And you've got to allow them the space and the time to do that. And doing this got us, over the space of about 3 years, to, I think, what most people will call continuous delivery. We were releasing to production usually once a day. Developers were checking into master every day. We didn't really use branches. Maybe we'd have a branch if it lived for less than a day was okay, but otherwise we didn't use them. We had automated processes to do most of this, but we still had a separate ops team. But that ops team was integrated with dev. They'd come and sit with the developers. They'd attend sprint planning. They would inject their own requirements into a sprint. And it worked pretty well. So over the course of the 3 years, we saw something like this. And this isn't, I appreciate, hugely useful because it doesn't have any axes on it. But anyway, the number of releases we saw went from very few to multiple times a day. The number of bugs that we saw over those 3 years went from, I think it was 180 reported every month when we started, down to 1 or 2. And uptime went from 98.5, something like that, all the way up to 99.998. So the difference it made was profound. And the difference then started to seed out to the other parts of the organisation as well, because all of a sudden marketing could do things differently, product could do things differently. And it started changes in the rest of the organisation. So that's DevOps. In Tesco, we took a totally different approach. Similar problem, waterfall development with a big monolith that's difficult to change, but a much larger scale. So thousands of developers, not just 50. And what we decided to do at Tesco was use Conway's law to our advantage. So Conway's law basically says whatever system you design, it's going to reflect the organisational structure or the communication structures of your company. So if you accept that, what you can do is structure your company as you want your system to look, and then it should naturally evolve. So that's what we did. We broke our organisation up into 42 different domains, all sort of business domains that someone from the business would understand: identity, price, contact, location, things like that. And set up autonomous teams around each of these areas, in the hope that what this would bring was a service-based architecture with each of those organisational groupings as a service. But instead of those teams being development teams that then handed off to an ops organisation, we said, well, you build it, you run it. And this you build it, you run it statement is something that Werner Vogel said, the CTO of Amazon, about a decade ago, when they started moving to a service-based approach. And he said that this one statement made a huge difference in the quality of their services, both from a business and from a technology standpoint. Putting developers on call was a good thing. It made them appreciate the ops team, I guess. It made them get annoyed about being woken up in the middle of the night and come back and fix the system so it didn't happen again. And so this is what we did. We gave the teams full autonomy to do whatever they liked within their team. They could build using whatever infrastructure they wanted. There was a data center they could take advantage of, or they could go into the cloud. They could use whatever processes, tools that they wanted to use. But they were responsible from all the way from an idea through to production, and they had to support it in production. But at the same time, we understood that we were also asking them for a system that was highly available, and that there would be a lot of redesign of the existing system in order to make that happen. And that takes time. It also takes a certain type of person. Because all of a sudden, you're asking a developer to do different things. They're not just writing Java code anymore. They've got to understand your platform. They've got to understand Kubernetes. They've got to understand containers. They've got to understand monitoring. They've got to understand what to monitor. They've got to understand alerting. They've got to understand the network stack. You know, all of these things that maybe are traditionally more operational concerns, your developers are now responsible for. And this is tough. You're asking people to specialize in multiple things. And what we were looking for was E-shaped engineers. People with 2, 3, 4 different areas of specialization. Not just the one. You know, you've probably heard the phrase of a T-shaped engineer who's got broad skills and then one area of specialization. We were looking for people with more areas of specialization than that. And they're really hard to find. There's not very many of them. And the ones that exist, they're really hard to get hold of because everyone wants them. And they can get a job anywhere. So clearly we couldn't just recruit in a bunch of these people because it was too difficult. What we had to do was grow our existing engineers into these E-shaped engineers. And that meant, again, investing time, effort in learning, in education. And just generally raising the bar on what we considered acceptable for an engineer. So along with those high expectations, though, we gave them space to learn. So, for example, in the area that I was working in, we had one day a month where no one did anything. Everyone came into the office, didn't do any work, and all it was a learning day. And you could use that learning day however you wanted. There were plenty of talks put on for you. There was technical talks, there was talks about Agile, there was talks about operations, there was talks about security. Or you could sit at your desk and read a book. If that's the way that you learn, fine. Or you could do one of the online courses that we'd got, you know. But just giving people space to acquire these new skills that we were asking them to have. And we also realised that people want career progression. Right? You want to go somewhere in your career. And typically, certainly a lot of companies in the UK anyway, you get to a certain point and really you have to go down that management route. That's the only way to progress your career. That's the only way to get paid more. And what we wanted to do was change that. So we wanted techies to be recognised for their technical excellence. So that's what we did. We created a path that you can go all the way up to the same level of seniority as our CTO and still be a techie. Still write code day in, day out. And that gave people some, I think, inspiration to improve as well. And lots of our ops colleagues have really flourished in this environment. So, you know, we're asking a lot of someone in ops to say, right, come and sit in this development team. You're going to be writing production code. You're also going to be writing infrastructure code. And you're going to be running the system. And you're going to be writing tests. And it's like, well, okay, I've never done that before. So we had to give lots of people support through that. But plenty of people have taken us up on that and really flourished. Now, one of the key differences by having this makeup of team, a team that's made up primarily of engineers, is that automation, the drive to automate, is a lot higher. And perhaps that's because engineers already have the tools to do the automation. They're used to writing code. Code's the answer to everything, right? And they start to apply that to all of these problems that we have. But interestingly, even at SagePay, we were doing things like infrastructure as code. And that infrastructure, you have to treat it like your production code. You have to take as much care of it as you take of your production code. Otherwise, it goes stale really quickly. And the thing that I noticed about having a team full of engineers do this was that curation of the code, the caring for the code, happened a lot more, particularly around the infrastructure components. So we would regularly have debates about refactoring our Ansible scripts, or our Bash scripts, or our Python scripts that were building infrastructure and provisioning servers. And that makes a real difference in the long term, because ultimately you're going to be able to maintain your infrastructure. We also had a strong drive to embrace open source, right? To really get that open source mindset, and to use all of the fantastic tools that are out there in the kind of DevOps and cloud native worlds, things like Kubernetes. And rather than buying things, rather than spending money on commercial products, what we spent that money on was hiring people in that were really good at with those open source stacks. And that, again, paid dividends because their knowledge then was seeded throughout the rest of the organisation. People learned from them. And so with a bunch of engineers that are really happy to automate and really happy to play with new shiny toys, I think we probably aimed a lot higher. So we were happy to look at new data persistence technologies, to take Cassandra and make it work, much more so than we were at SagePay, because we were tempered by the ops guys saying, oh, hold on a minute, do we really know how to run this? And that's a double-edged sword. It means you get a lot of innovation and you can reap some of the benefits of it, but also sometimes things go wrong. Sometimes things don't work quite as you expect them to work. And I think one of the comments that I've had from people that have joined our teams is that perhaps we aim too high. Perhaps we shouldn't be trying to do so much architectural change at the same time as doing features, at the same time as putting in a new data persistence layer. But actually the teams take a pragmatic view on this, right? So they aim high, but actually when it comes down to it, if something's not going to work, they're pragmatic enough to say so, to reverse the decision that they made and do the right thing. And I think that part of that is around the trust and the no blame culture that we were talking about earlier. So in Tesco, where did we end up? Well, we ended up on the cloud, for a start. We ended up doing continuous deployment. Every time you push to master, it gets picked up by the pipeline. If the pipeline goes green, it goes into production. So we were doing multiple releases a day. A little scary, but worked very well, and meant that we could get a lot of small changes out that might otherwise not have got into a sprint. And some of those changes we saw were around latency. Because when you've got something that's going slow, sometimes it's only a really small change. It just takes someone drilling down and down and down and down and down until they get to the thing that's a little bit slow. It's a small tweak, and you can shave hundreds of milliseconds off response time quite easily. And we saw that happen a lot. And some of that is down to, I think, having engineers engaged in operations, and some of it's down to it being really easy to release things. So one of the problems that at least the perception of a problem that we had, was that, well, we've got loads of these different teams and they're all doing whatever they want in their own way on whatever cloud that they wanted to use, using whatever tools they wanted, using whatever data storage they wanted. Surely this is like anarchy, it's like chaos. And to start off with, it was. Everyone was doing their own thing. But very soon, people didn't want to do their own thing anymore because it was a lot of effort. It's a lot of effort to get a new data storage technology, put it into production and keep it highly available. So people had a kind of intrinsic motivation to use what other people had done. And we started to see standards evolving naturally. Someone will say, oh look, I've got this really good Jenkins installation, why don't you just use that? Or we've already got the Ansible scripts for building those types of servers, why don't you just take ours? And so over time, and it wasn't very much time, over about 9 to 12 months I'd say, standards started to evolve and they kept on evolving, which felt like the organisation was staying very current. And I guess lastly, we had teams full of these E-shaped engineers that were really good. Right? They had a wide variety of skills, they had diverse skills, and it made it a really, really fun place to work because you're learning all the time, because these people are teaching you stuff that you didn't know. So just to kind of sum it up, 2 different approaches to the same problem. DevOps is probably less of a change, but make no mistake, it is still a big change. You're asking your ops team to get involved with development. You're asking your developers to open up to your operations team. It's a massive change, but it's less of a change than taking the you build it, you run it approach. It's much easier to recruit people for a DevOps type role. It's really, really hard to recruit people for a you build it, you run it, a NoOps type role. They're very few and far between. Sometimes I think with NoOps you lose some of that operational excellence. You sometimes forget things slip under the carpet. It's just the nature of it, because it's not people's primary mindset. But the counter to that is that it could be harder to do new things in a DevOps environment because you've got that traditional approach sitting on your shoulders, always going, oh, are you sure that will work? Are you sure that will work? And that can be stifling. Either way, you've got to invest massively in education, in learning, in giving people the time and space to learn these things. And do you want to take more risks or do you want to be more conservative? That's not a question that I can answer. That's a question that you've got to think about for yourselves, for your company, and the domain that you're in. So I'm going to finish off now with just 2 points. Whenever you start on any kind of transformation journey, don't expect that what worked at the start to carry on working. It's not going to. You need to evolve your approach. And sometimes you need to do a complete U-turn on decisions that you thought were right. And I'm going to leave you with this. This for me is the most important thing about DevOps, about having a HA system, is everyone together right from the start. Thank you.
Thank you very much. Okay. I won't do that again. Okay. So let's take a few questions while we gather the crowd from the other side, because we're going to do our closing keynote in a second. Let's begin here.
Thank you. So have you gotten completely rid of the DevOps department as dedicated people? So do you no longer have DevOps at all and only have E-shaped engineers? And how do you handle urgent work, like a cluster went down or something unexpected in the Scrum framework? So if there is any unexpected work, I assume it usually is.
So the answer to that question, certainly in Tesco, is no. For the teams that have taken an autonomous approach, we don't have any ops organisation. So if something goes wrong, so if our boards go red or our phones start ringing, we drop everything and deal with it. Generally, we have people who are assigned on a rotating basis. Everyone gets a go at doing that. And if it does spawn a much larger piece of work, then that's a conversation with our product owner to say, look, is this important enough for us to stop this sprint and fix it? It means that our product owners are much more aware of the operational side of the system than they otherwise would be.
Okay, we have a question back here.
Hi, thanks for the great talk. When you said that each team used its own tools and technologies, which was the communication channel that they could communicate what they're using so that the other teams could get it and use it since it was implemented?
So the question is, how did teams communicate the tools and technologies that they were using? And I guess it was probably in two ways. There was a very formal way where we had a SharePoint site with some kind of architecture documents on, and every so often those would be updated. I think the primary way was on Slack, is that all of the teams would be in a common channel and would just be telling people about what they did. We had this kind of way of almost working out loud, so people would be very verbose in Slack about telling all the other teams what they were doing. A conversation would spin off, then maybe if there was interest from the other teams, a new repo would pop up, and that repo would be advertised in Slack.
Okay, question in the middle there. Nobody in the front? Nobody got any questions? Makes it easier for me to answer questions in the front than in the back.
Hi there.
Hi.
How did employee attrition rates change after your move to E-shaped engineers and NoOps?
How did the implementation of what? Sorry?
Employee attrition rate after you moved to
So employee attrition rate after we moved to E-shaped engineers. So I think we probably recruit continuously. We never stop recruiting really, and whenever we see someone that's got those skills, we pick them up, and generally when they get into the teams, they're really happy. There was people that really flourished in this environment because they really wanted to learn and they really wanted to get new skills, and this was the perfect environment for them. And then yes, there was a bunch of people that it wasn't right for, and those people moved on.
Let's take a few more. Any questions?
Any more questions?
Any more questions? Go on. So it's not often we're going to have Mr. Software of Tesco here. So let's take advantage of this, right? Any retail type questions that you might want to ask? Okay, I think everyone's quite satisfied. Thank you very, very much.
Thanks very much.
Okay, good.